In this video, we are going to revise the flowchart symbols that we need to know for the exam, and we're also going to do some past paper questions that are related to flowcharts. So firstly, as to why we use flowcharts, this textbook explains it pretty well. Flowcharts are used to show the steps required to complete a task and the order in which these steps are to be performed in a diagram format. So these are some examples. So by using different shapes with different purposes and connecting them with arrows that point the direction we read from, this provides a way to visually communicate how a system works. Okay, now on to the 5 symbols that we need to know. The first one is the terminator, which looks like this. It's a rectangle, but the edges are really rounded. And so inside of this, we write either the word start or stop, and then we put them at the beginning and the end of the page usually. So the start indicates where the reader should start reading from, and the stop indicates where the flowchart ends. Next is the process. So this one is just a rectangle shape, and it represents an action that is being done. So a common example is to use it to represent when a variable is being assigned. For example, true being assigned to A. And you don't necessarily have to put every single line into its own box. You can also group them together into one box if they are related to each other. Next is the symbol for subroutines. So it looks kind of like the process, except that there are 2 lines here. So this represents a call to a subroutine, but the steps of this subroutine is inside of a separate flowchart. Okay, so I put 2 examples here. In this one, the user has to input a value that is stored into this variable user ID, and then the contents of this is passed into a subroutine called getAverage, and then the results of this subroutine will be stored inside of this variable called average. So inside of this flowchart, we are calling a subroutine called getAverage, but the steps of this subroutine, like the steps inside of here, is not going to be shown inside of this particular flowchart. It is inside a separate flowchart. So maybe this getAverage executes like 5 steps, but it has its own flowchart to show those 5 steps. It's not inside of the current flowchart that we're looking at right now. And then this is another example. So we have this subroutine called update, and then we pass it to values, and then we call it inside of the flowchart. But then the steps that are executed is not shown here. Like you see, it just jumps to the end terminator. But there are steps being executed. It's just that it's not shown in this flowchart. We're just calling the subroutine from a different flowchart. Okay, so for inputs and outputs, we use this parallelogram. And then inside of it, we write the pseudocode of what we want to be inputted or outputted. We could get the user to input something into a variable, or we output the contents of a variable, or we can also add like a meaningful message alongside the variable contents. Okay, and finally, we have the symbol for decisions. So this is using this diamond shape, and inside of it, we write a question. So for example, is value less than or equal to 100? And then we have 2 branches coming out of it. So it's either yes and no, or it could be true and false. So it depends on the question inside. So the program will have to check the condition inside of the diamond, and then it will follow the path based on which one matches the current state of that decision. So these decision diamonds can be arranged to represent iteration and also selection. Okay, for selection, it can be through something like this. So this is just an example. Is code store count equal to code? And then yes and no. So this sort of resembles an if statement, right? It's like if code store counts equals code, then do this, else do this. So this acts like a selection decision. And then as for iteration, it will be something like this, where we have a counter. So is count greater than 6? So if it's yes, then we go here. But if it's not, then we repeat everything here until this count is greater than 6. So this is a loop, it's iteration, because we'll keep repeating until this condition is met. Usually we draw the flowchart from the top to the bottom and left to the right like this. But there also are cases where we have to draw the branches going from right to left as well. So it depends on the question scenario, but as long as you lay out the whole diagram in a way that is neat and easy for the reader to read from, it should be okay. Okay, so I've got 3 questions that we'll be doing today. The first one is to practice reading a flowchart and then filling in a trace table. The second one is to fill in the blanks of this flowchart using this scenario. So they already drew the boxes for us. We just have to figure out what to put inside. Then this last one is to draw the entire flowchart from the scenario from scratch. Okay, so let's look at this one first. The flowchart represents an algorithm, and then it gives us a flowchart. Then complete the tables using the flowchart for the given data, and the input data is 20. Okay, so they didn't give us like any hints on what scenario this flowchart represents, so we have to go through each of the flowchart symbols one by one. Okay, so first we have a start terminator, and then we initialize count to 0. After that, the user has to input a value, which is stored in this variable called number. This value, inside number, is multiplied with the number in count, which is currently 0. So they're multiplied together, and then they are stored inside of this variable called value. After that, the contents of value is checked. So is value less than or equal to 100? If it is, we increment count. We calculate the number that's stored inside value, and then we check value again. So this process will keep repeating until value is no longer less than or equal to 100, right? So meaning to say that value has to become greater than 100 for this no to be met. And then count is decremented once, and then the value of count is outputted, and then we reach the end of the program. The first thing that is done is that count is initialized to 0. So I'm going to write that here. And then number is inputted. So we are given 20 as our input data. So I will just put that there. And then we calculate what's stored inside a value. So we take count times number, which is 0 times 20, and this is going to be 0. And then we check, is value less than or equal to 100? Right now, value is 0. So yes, it is less than 100. So we go here. So we increment count by 1. So this changes to 1. And then here we recalculate value. So it's going to be 1 times 20, which is going to be 20. And then we check again, is value less than or equal to 100? Yes, it still is. So we increment count and then recalculate value. So now 2 times 20 is 40. And this whole process will just keep repeating. So let me just quickly fill up the next steps. So after recalculating here, I've reached value equals 5 times 20, which is 100. So I check, is value less than or equal to 100? Yes, 100 in this case is still equal to 100. So we go here. So count increments by 1. Values recalculated. So we get 6 times 20, which is 120. So now 120 is finally greater than 100, right? It's not less than or equal to 100. So we go here, then count decrements by 1. So I'm going to put 5 because 6 minus 1 is 5. And then we output count. So the current value of count is outputted. So we output 5. So I wrote 5 into this output column. Okay, so here's the mark scheme. So yeah, they give marks per column when it comes to trace table questions, and everything all matches up. So basically, when we read flowcharts, we always read from where the arrows are pointing. You must always follow all the arrows and the directions that they point at. And then for the yes and no branches, like be careful to read what is the condition properly and then follow the yes and no accordingly. Okay, and so now we're going to do this question. So already from looking at it, it's a question where you have to fill in the blanks by using this scenario. So let's read it. The flowchart shows an algorithm used for quality control on a biscuit production line. The weight of each biscuit is entered into the variable weight. If the weight of the biscuit is between 16.2 and 17.2 grams inclusive, the pass counter is incremented by 1. Otherwise, the reject counter is incremented by 1. The process continues until -1 is entered, after which the totals for pass and reject counters are output. So already from reading this, there are already like a few hints on what you're supposed to do, like even without looking at this. The weight of each biscuit is entered into this variable weight. So this is like hinting that the user will have to input it. So I'll make a note of this. So we need to input the weight. So I'm just writing this as like a small plan. If the weight of the biscuit is between these two, the pass counter is incremented. Otherwise, the reject. So already this is an if and otherwise. So this is hinting at the decision diamond. Okay, I will like just write in short in short form, because this is just a plan and we're not getting marks for it. So if the weight is between these two, then the pass will be incremented. Otherwise, the reject will be incremented. And then the process continues until -1 is entered. So this until keyword means that this process here will have to repeat until this condition is met. So this is like a repeat until loop. So this is also going to be like using a decision diamond because we have to keep checking until -1 is entered. So we have to check the weight when it's input, right? So we put check is weight 1. This will branch to yes. So if yes, wait, no, sorry, there should be if no, because we repeat until this is met. So this one will execute if it is not. And then if it is -1, then we output the pass and reject counters. So output pass and reject. Yeah, okay. So this is the plan that we have going on. We input the weight, check if it is -1. So if it is not, then we do these. We check that the weight is in between these two, and then we increment the pass counter. But otherwise, if it's not, then we increment the reject counter, and then we go back here and keep repeating until it is -1, in which case we go here, and then we output the pass and reject. So this is the plan we have going on. And now we can fill in the flowchart. Okay, so firstly, we have the start terminator, and then we initialize pass count and reject count to 0. And this is the input. So yeah, this follows what we know, that here the input should be to input the weight. So okay, here we're going to input the weight. Okay, and then we have this decision diamond. So this, it should be for the check of the weight. And we need to put it in the format of a question. So I'll put is weight equal to -1. And then we branch to yes and no. So if it is no, then we have to check this condition. We need to check is weight greater than or equal to 16.2, and is weight less than or equal to 17.2. Because it must be in between and it must be inclusive. So I'll just put this here. If it is correct, so if this statement is true, then we go here. Otherwise, we go here. So the pass counter should be incremented. So pass count will be incremented. But otherwise, reject count will be incremented. Okay, so we're done on this side. And then, yeah, so you can see that these both have a branch that goes back to here so that the loop can be restarted again. But then as for this side, if the weight is equal to -1, then we should do these two. So we should output the pass and reject. And yeah, we have we have two input output boxes. So yeah, these should be to output the pass count and the reject count. So yeah, it's a 6-mark question. And then you get marks for inputting the weight. Correct check for is weight equal to -1. Correct check that is in between these two. And then the increments for pass count and reject count, and then outputting pass count and reject count. I would say in short, what you should do is that you should analyze the scenario and then make a plan. Check that the logic follows the scenario, and then you fill it in accordingly. So that's it for this question. Okay, now on to the final question, where we actually draw up our own flowchart from scratch. A programmer is designing an algorithm to calculate the cost of a length of rope. The program requirements are input 2 values, the length of rope in meters, length, and the cost of 1 meter, cost. Perform a validation check on the length to ensure that the value is between 0.5 and 6 inclusive. Calculate the price. Output the price rounded to 2 decimal places. Use the variable names given. Okay. So firstly, state the name of the validation check. Okay, so the validation check is referring to this one. So it is a check on the length to ensure that the value is between these two values inclusive. It is a range check, right? Because we're checking that the length is in between these two. So yeah, this is a range check. And then as for the flowchart for this algorithm, okay, so first we should make a little plan. The first bullet point says that we input two values. So we input length and the cost. So input cost. And then we do the validation check on the length to ensure that the value is in between these two. So is so it's kind of open-ended on what happens if it is not. As in like if it's kind of open-ended on what we're supposed to do if the check fails, right? Like obviously if the check succeeds, then we go to here. But then if the check fails, I guess we can assume that we need to re-input the values, right? Okay, I'm not writing in like proper pseudocode because again, this is just a plan. So if it falls in between the values, then we calculate price and then we output the price. So I'll do something like this, then calculate price. Output price in two decimal places. Else, if this does not fulfill the check, then we will go back to step one. So we'll just jump back here and ask the user to re-input the length and the cost, I suppose. Or otherwise, we could only input the costs if the check succeeds. So meaning to say that if the length check actually passes, only then we ask them to input the cost. So yeah, I think this would work too. Okay, now that we have a plan, let's draw out the flowchart. So we are given just the start terminator and the stop terminator. So firstly, we have to input the length. So inputs and outputs use the parallelogram. We're just going to put one immediately below the start. Okay, so make sure that in the actual exam, you use a ruler to properly draw out all the lines and also the arrows. And then you write everything inside legibly. So perhaps you could like write out the words first. So you could write out input length first, and only then you draw the box around it so that you can properly gauge how much space you need rather than like squishing your handwriting inside the shapes you draw. Okay, then after this, we have this if check. So this should be using the decision diamond. So we need to word it like a question. So we say, is length greater than or equal to 0.5? Right? And also it is less than or equal to 6.0. So we have the arrow joining to here. Okay, so we should have a yes branch and also a no branch, right? So for yes, meaning that this condition is met, then we do these three. But if not, then we go back to step one. So okay, so that means that if it's no, we just have an arrow that goes like up to here. Okay, so now we have the yes and no. So now we have to add an input box for inputting the cost. So I'll just copy this. So we input the cost and then calculating the price and outputting the price. So for calculating the price, it is a process. So we just use a rectangle box. Okay, so we are given the length of the rope in meters and also the cost of 1 meter. And we need to calculate price, which is the cost of the total length of the rope. So for example, if you're given like 10 meters and then the cost is like 5, like cost for 1 meter is 5, then the total price will be 10 times 5. So yeah, even though the formula is not directly stated, this is something that we should be able to infer. So price is going to be equal to length times cost. Okay, and finally, we need to output the price in 2 decimal places. So I'm going to just put output. Do you remember the pseudocode for that is using the round function, price 2. You can also put like the word price in front, put a comma. So like the output has a meaningful message. So output price, wait for colon, price, and then the price in 2 decimal places. And yeah, that's basically it. So here is the mark scheme. For question A, range check is correct because we're checking that the value is within the given range. And then for the flow chart, I'll put this here. Oh yeah, make sure in the exam you use like this like straight speech marks like this. Try to like avoid writing it like this. Okay, so we get 1 mark from using these points. Correct flowchart symbols, working flow lines, and complete. Both inputs correct, working range check. broken calculation, correct output rounded to 2 decimal places. So yeah, that's basically it for this question. So in the exam, what you can do to like make sure that all the stuff on your flowchart is well spaced, what you can do is like before you draw out any of the boxes and stuff, you write out the words first. So if you write out all the words and then you see that like, oh yeah, it's evenly spaced, only then you draw the boxes. But if you find that, oh, I'm actually kind of running out of space at the bottom, you're going to have to like erase the stuff and then like shift it up a bit. But at least you didn't like waste time drawing too many of the boxes. So like, yeah, you write it out first and only then you draw. If you have any questions, please leave them in the comments. And thank you so much for watching.